all for this class. Today we are going to learn about in the solid mechanics class laws of uniform cross-section in the solid mechanics. Okay. So here we are going to take a bar which is consisting of two or different sections. Okay. One or two different sections is taken, and it is determined by a load P. Here also the load same. It is uniform cross-section. Then I am taking that the sections A 1, 2, 3. These sections are there. So I can take a representation A, B, C, D. Okay. So now what is the thing is I am going to find the total extension. Okay, what about the extension here? So this is L1, this is L2, this is L3. So put together L1 plus L2 plus L3 is called the total extension since it is a tensile load. Okay, if it is a compressive load, this is there will be a decrement in the length. So my aim, how to find the axial deformation? First of all, we should know. Okay, from Hooke's law, the stress by strain. Okay, stress by strain equal to Young's modulus. Okay, and what is strain here? So strain equal to stress by Young's modulus. So we can have that stress equal to load by area, and this one as it is Young's modulus. Okay, for E is equal to P into P by AE, which is equal to delta L by L. That is the strain. So from that, what is delta L? Okay, so delta L refers to P L by AE. So change in length, that is axial deformation, that is equal to PL by AE. That is the mathematical expression. That is the thing we are going to apply here. Okay. So since it is a constant area, okay, uniform cross section, and let's take in this here, Young's modulus depends on material. So I am going to have this section is made up of material. Let's take E1. Since it is a material, different material, let's take E1, and this is E2. This is E3. E1 and E2, E3 all are equal if like three sections are made up of uniform material or single material. Okay. Now let's take these are all different material. So the material depends representation given by the Young's modulus varies. So how to find? So I can find what is the first section, delta L1, delta L2, delta L3. So like that I am going to apply. Since I know that delta L is equal to PL by AE, okay, and here the load, since it is added on by a single load is constant. That means the load at section 1 and section 2 and section 3 all are equal. Okay, so here PL by AE. So here like this for first section is L1, the first material is E1, and area is constant cross-sectional area. So PL by AE1. Like that, it is also same thing PL2 by AE2. Here PL3 by AE3. Okay. So finally, what is the total elongation? So total elongation we can write just like this. Total elongation is equal to delta L1 plus delta L2 plus delta L3. You have to sum up all these things. So finally, this delta L equal to, since this load is constant and area is constant load, one thing is we are having a difference in the length. Okay, length and the Young's modulus. So L1 by E1 plus L2 by E2, L3 by E2. Simply it is nothing but PL by AE. That's all. Okay. So for each section it will vary. If everything is same, that means materials are same, this E1, E2, E3 both are equal to E, then it will come as common outside. Okay, only thing is the length is changing. Okay, so that's all about this class. How to find the total extension. Okay, how to find the total extension if the cross section is uniform and given that a single common load as well as the materials for each section is different. How to find? Because Young's modulus, even the length is same, as well as load is same, area is same, but there will be a change in delta L1, delta L2. There will be a difference because of what? Because of material. Already told Young's modulus depends on the Young's material. If the values are higher, the resistance, that means it will give the resistance, okay, for deformation. Okay, so here material 1, material 2, material 3 different, so it will not be equal. Even the loads are same, even the length is same. Okay. Only the thing is, if all the 3 sections made of one single material, it is uniform deformation in each section. We can easily that 3 times PL by AL we can get it. Okay. So this is about the loss of uniform cross section with applying constant load. How to find the total extension. Okay, we will have another session in solid mechanics class with a different topic in the next class. Thank you.